an intro to EMF, and I've done that sort of 1,000 times already, so that was relatively boring for me, and I thought probably a lot of you already know EMF. Who here does not know EMF or what Xcore is? That's like nobody. So this is a good idea then. I thought I'll do something a little different, so it's interesting even for people who know EMF well already. So I thought I'd explain a little bit some of the history of how EMF came to be out in open source, what all started that. So in the beginning there was MOF. When I was at IBM, we had this thing called MOF, an implementation of MOF, and all of the tools groups were forced to use it. So a lot of the people, when they thought, well, what is MOF really for? It was totally clear to them why they were forced to use it and what MOF was all about. So you really needed to explain to them, well, MOF is about the ability to model all models. So it's really about this core meta model that you can use to describe itself and that you can just use to describe any other model like UML or XML schema or whatever you happen to be building. So the people that were in charge, they were quite pushy people, and they had a lot to say, a lot of opinions that were relatively ill-informed according to our feeling about it. And the first thing they told us is, you can't remove anything from MOF. Like, what's there is super important, and brilliant people designed this, and really everything that you see in MOF is completely essential. So we kind of doubted this, and at the time I'd done a couple of patents, and I went to this meeting where they were like, you should feel empowered and you should innovate. And so I thought, all this stuff in MOF, do we really need all of this stuff? And nobody could answer that question. So what I started doing was deleting things and see what broke, because we had this giant test suite and knew all of the use cases. So I deleted things, and I could delete a lot of things, like half of it was gone and everything was still working. So that's what we said, no, this stuff that you say is all essential is not essential. And this part that's left over, this is what we see is actually used and therefore is essential. And the powers that be were not completely stupid, so they saw this was actually a good thing. And the OMG saw that it was a good thing, and so they took Xcore and changed it a little bit and called it EMOF. But essentially our effort to simplify MOF was then standardized, and Xcore is essentially an implementation of the OMG standard, and these slight differences are just differences you can tweak in the serialization. So Xcore and OMG's EMOF are isomorphic. So not only did we design Xcore, but the giant bloated runtime that everyone was getting ready to jettison, we rewrote that from scratch with the point to make it sort of lean and mean, efficient and small. But the powers that be were kind of concerned that we were spending a lot of effort on this, and they made some very strange assertions. They asserted that there's no point in fussing with the software so much because all software is rewritten every 5 years anyway. Well, EMF is a lot older than 5 years now, so that was clearly wrong. But you see these kind of attitudes, they're sort of self-fulfilling. If you don't work hard on your software, of course it will be rewritten every 5 years. And that's in fact what we were doing, was taking the old crappy bloated runtime and rewriting it. So they thought this was a fact, but in the end, if you fuss on your software, it will last a lot longer than 5 years. Worst of all, they told us we had to replicate all of the old bugs in the old runtime before we could fix them, so they could see what exactly we were changing. So that pretty much sums up our reaction to that. Like, no way are we going to take a working runtime and change it to reproduce bugs so that we can change it again to remove them. Like, no, that's not going to happen. So around this time, the powers that be thought, well, open sourcing is good. They had Eclipse, and they decided to open source EMF to Eclipse. Well, actually not EMF. They decided to open source XSD. That was the implementation of XML schema that we did. It was one of the first major projects that we used the new runtime to develop. And that's what they wanted to open source, because that was the days when all things XML were good and XML schema was just the spice on top of the goodness. So they wanted to promote that and open source XSD. So they kind of, oops, accidentally open sourced EMF. And they really didn't think hard about all the implications of having done that. So now EMF is open source and people see the functionality that's available there. And of course, I'm inclined to help people a lot. And so I got this brilliant advice from the powers that be that you shouldn't be too helpful. There's kind of some helpfulness balance you need to achieve. And if you're too helpful, you will damage your community. I never have figured this out, how you could damage a community by helping them, but apparently that's possible. They also complained that they couldn't coax their business partners to use EMF because it was proprietary. And it's like, well, it's an implementation of a standard and it's open source, so I don't really see what the problem is, but they said, well, let's create this thing called SDO and we'll hide EMF behind SDO. And SDO will be simpler and that will make it easier. How many people have heard of SDO, know what SDO is? Like not many. So that tells you how successful that effort was, right? Like you're all using EMF, but SDO, God knows what that is. And then they also asserted to us that the customers that are using the products, they're not actually interested in any of the features that EMF provides. We thought, well, cool, like we can do so much. With a simple model, you can generate an editor and serialize your instances. Like, it's a pretty powerful thing. But the customers, we're told, are not interested. So of course, it begs the question, what are the customers doing with our tools? And I asked that question, and I was told, well, they use it to draw pretty pictures. And I thought, you're kidding me, we're building a business model around drawing pretty pictures? Like that can't really make sense. Didn't make sense to me, but again, it seems to me a self-fulfilling type of thing. If that's all you think the customers want to do, and that's all you really enable the customers to do, that's probably all they'll be able to do. So naively, we sort of believed in all of the principles that the company represented. So we really tried hard to show dedication to every client's success. And I went to the sort of executive interviews and was like, look at what I did for our customers. And then I realized there's kind of a caveat to this dedication, that if they've already spent their money, making them successful is not as important as if they haven't spent their money yet. And of course, with open source, they're never going to spend any money. So whatever I did for open source was really not really all that important. But being principled, you always believe, like if you work hard, you will be rewarded. So I worked my butt off to fix all bugs and answer all questions. And the result was a dramatic reduction in the size of my team, if you can consider that some type of reward. And it's like in a big company, the problem is the team with the most problems, the biggest backlog of problems, the most defects. The team that's least well managed is the one that needs the most people. And the one that fixes all their problems and is running smoothly clearly has more than enough people. So it's sort of inevitable that this thing will happen. But the powers that be missed one really important key thing, this don't put all of your eggs in one basket principle. So my team was reduced to less and less people, and I have this little basket of eggs in my hands. And I said to them, so long and thanks for all the open source, and walked away and had complete control over the project that's being used in hundreds of their products. So this is something to keep in mind. You people are all working on projects where you're probably extremely empowered and you have a lot of control that you might need to go somewhere else to exercise that control. But we as developers run the world, and we have portable skills that go wherever we take them. Keep that in mind of how empowered you are. And since then, that's really an empowering thing for the Eclipse community, that I was no longer sort of saddled to one company, could work as an independent and promote everybody's projects and really not feel like I have to balance that against the benefits of any one company. So since then, this sort of core framework that started has just, it's like layers of an onion. People have built all kinds of incredible things around it, cool graphical technology, textual technology, transformation, serialization, formats, you name it. And the rest of the day you'll hear a lot of those kind of details. I have just under 15 minutes left to show a little bit of sort of what you can do just with core EMF. And because I'm old, I can't see with glasses. Well, I can't see you now, but at least I can see my screen. Okay, so I have a blank new workspace. I think this is pretty much the oxygen level of stuff, but I have a few new things that I've developed for Photon that I can show you as well. So the basic idea is you start to create a new project. It'll be an empty EMF project in this case. I'll call it org example simple. If I can type still. And it just creates a basic sort of plug-in project with some basic Java stuff, has a Java nature. And in the model folder then, I can create a new Xcore model. And I'll call that simple. And a nice thing with the sort of this structured editor, it does live validation. So make sure if you're using this editor that live validation is enabled. For any model that you develop, you can also enable live validation for it. So what you see in this Xcore editor is pretty much what you can generate for any model of your own models that you work on. So all of these things are errors. They can't be unspecified. So we'll call the name of the package as simple. We'll make that the package prefix and the unique identifier for it. Example.org. So now the model is complete. So the package is like a Java package. It's basically just a placeholder. So the most important kinds of things you try to create are things like classes. So I'll create a class here that I'll call node. A little bit of feedback, or is that? So under a node, I'll create an attribute that I'll call label. And it will be of type eString. So the attributes on a class are basically, they're always of a data type, and they're sort of the leaf bits of data in your modeled representations. The references are the things that form the links between the objects in your representation. So here we have a node, and a node will have a reference called children. The upper bound will be -1. There's an arbitrary number of them. And it's a containment reference. So that's something new that you see here, that in the Photon release, there will really be cell editors that are checkbox cell editors, rather than the drop-downs that we had before. And this will be of type node. So we could also have a container reference that's the opposite of the children. So we could have a reference that we'll call parent. And it will also be of type node. And its opposite will be children. So this is sort of the obvious sort of simple data structure of nodes contain other nodes forming a tree. A couple things that I've added recently are better support for annotations. So I can go, for example, to this children node and add an annotation. And the model, from the registrations, it knows Xcore or annotation models that have been registered, and it knows the structure of. So I can add an extended metadata annotation. And in that case, it suggests to me what properties I can set on this thing. So I can say, I want this thing serialized as an element. And when it serializes, because there will be more than one such element, instead of calling each one children, it's probably nicer in the serialization if that element itself is called child. And what you can also do is add your gen model annotations. So for example, I can add an annotation here and choose gen model. And then all of the properties of a gen model are available here as if I was in the gen model in the generator editor. So here I could say the base package is org.example. I might also do such a thing on the parent because it'll have a getter and a setter, but I might want to suppress the setter, so you can't just say set the parent, you have to add to the children, just as an example. So I could make the visibility of the setter suppressed. So given a model like this now, I can generate code from it. I can also create a dynamic instance without generating code, but I'll show that with an Xcore model later. So we'll create a new generator model with that Xcore model as the import source. Oh, let me save him. So these models are smart, and it automatically reconciles if I reload the Xcore model. So at this point, we can just say generate everything. And it'll generate the entire model. We can look at one kind of useful thing is there's a generated example in the test project. I think the test project is generally not useful. You don't need to test generated code. It's like EMF is perfect, so there will never be anything wrong with it, usually. But there's this generated example that can be quite useful, that it tests everything standalone, so you can have a look at the instances it creates. So here we create a root node. I'll also create a child node, and I'll do root get children, add child. And then I can run this as a Java application, just as standalone. And you can see from the extended metadata annotation I added that this children feature is serialized as child. So that's the basic idea behind sort of Xcore and EMF, that it lets you define a simple or a complex data model, and you can generate code for that thing, including a complete editor with the properties view and so on. But a lot of times this sort of structured editor, it's a bit of a pain to use all these menus to create things and use the properties views to edit. A lot of times it feels more natural to take a textual approach. So I'll show how that's done with Xcore. So I'll create a new Xcore project. So again, these sort of empty projects are just a bunch of scaffolding. So I'll call it com example simple so it doesn't collide. And you see it's much the same kind of structure. It's got a source gen folder. I'll explain why in a minute. And we can create a new file called simple.xcore. So it's basically an Xtext type generated editor. There's a DSL that's basically mapped onto Xcore and gen model. So just with control space, it has to start with a package declaration. So I'll call it com.example.simple. And then next I can define things like imports. In this case, I want to define a class called node, and we'll have an attribute of type string called label. It will have a contains reference of type node, 0 or more of them, called children, and it will have a container reference of type node called parent. And the parent has to have an opposite. And the opposite has to be a feature on the other side of the type. So the only possible choice for the opposite is children. And when I choose that, opposites have to be paired, so it fills that in on the other side of the reference. And if I now save this, you'll notice the source gen folder up here is empty at this point. If I now save this, the code is automatically generated upon save. So it's a very natural process that you'd be used to with Java, and in fact, if you look at the syntax, it's really a lot like a Java syntax, just with a little bit more metadata that you know what's a reference and a containment reference, container reference, and so on. But it's designed to look very much like Java. You can also do nice things like define a derived feature of type string called qualified label. And you can define the computation for deriving that. So if the parent is null, then we just return the label. Otherwise, we can return. Now add this just for sort of null safety, but the parent.label plus slash, maybe I'll use the little one, plus label. So I can define logic, I can define the bodies of operations and so on. And in fact, this can be interpreted at runtime. So I can create an instance of a node, create a dynamic instance, and it'll open it up in the reflective editor, which is a little bit slow because it's reading in the entire gigantic Xcore model and Ecore model and all the underlying resources from the Java runtime. But I can do things like create a child, like you'd expect, and if I double click on him, I can set the label of him to be root, and on the child I can set his label to be child. And you'll see this, the computation for computing the qualified label is being emulated at runtime. This is not using the generated code, but rather interpreting the Xbase syntax in that getter at runtime. So that's the essential idea behind sort of the underlying features of EMF, this ability to define an Ecore model in various ways using the structured editor, using the Xcore editor. Cedric in a few minutes will show how to do that with the graphical Ecore tools editor. And with that, you define a data model that you can generate code with, or do all kinds of other sort of reflective-based runtime things with it. And then everything that you see that sort of works well with Ecore itself works just as well with your own specific models. So you can define a graphical view for your models, a structured editor for it, a textual editor in much the same way. That's sort of the power of all this meta modeling stuff. Whatever works for Ecore and is based on reflection just works uniformly for all models out of the box. I think I've just hit the on the dot. I have more time? Okay, then I can show more interesting things. So another feature that I've added very recently, so say this model is evolving and I add some other feature, string foo, to this model. But you know, I've got several releases and I really want to do proper versioning. So this feature, I might want to say that this is at since 2.14. So of course, the usual things that are generated, this documentation annotation will end up in the generated Java code. But these at since and at deprecated annotations are now processed in a special way. So if we look at the hover for foo, it shows, oops, trying to give that focus. If we look at the hover for foo, it shows all of the generated Java artifacts that are derived from foo. And I can use these to navigate them. So you'll see there's even things like constants generated in this literals interface and the package interface. So I can use this to navigate there and see that because of the attribute foo, there's this metadata in the literals package. And you'll notice here, it's got this at since annotation on it. So it's a nice feature now. The very first thing I did in Photon development was added this feature, and then I used it to annotate all of the things that I added for Photon, new enum literals and a bunch of new things to the generator model to support this annotation stuff I was showing. And so they're all nicely annotated properly with @since, which I used to have to go and do manually. So kind of a nice feature. Another nice feature here is the support for deprecation. So of course you wouldn't generally add it and then deprecate it, but one could. So you'll see even those come through. So you can deprecate things, and when it's deprecated in the Java doc, and you're generating for Java 1.5 at least, which I'm sure everyone does now, then that deprecation annotation comes through as well. So it's pretty useful new feature to add. Some other interesting things in terms of the structured editor, you'll notice that you can't resize this column anymore. And in fact, as I resize, you notice we're not getting this stupid line here, like you'd always get in something like the error log view. Oops. Come on. Probably have to give it focus again. Problems. We'll go to the problems view. So you'll see in the problems view, you often end up with these where things are scrolling away and you can't access them. You make them bigger, but then you're not maximized the window anymore. They're gone again. So with the latest version of the Xcore editor and all of the generated editors, you can say, I want the columns to auto size. So if it really is too narrow, you'll get a scroll bar, but it'll always be sort of the right size to fill up the space that you have. I already showed you some of the nice things like the little checkbox cell editor. With things like this, it's now possible to design a combo that you can edit the value directly or have a choice for the value. So in this case, you saw I changed the gen model annotation to something else, and that's not a recognized special annotation, so all of the structured information's gone, but as soon as I'm using an annotation for which the structure is known, then all of the sort of structure for it is there and there's proper validation for it. So all of the things that I show that's possible in the structured editor is also possible in the Xcore editor. I try to keep the two in sync. The only thing that's sort of nicer now in the structured editor is this properties view on the annotations themselves. In the Xcore editor, I really need to provide some better content assist for completing annotations, but it is possible in the Xcore editor to define these same types of annotations, like the @extended metadata and saying name equals child. I can do that in Xcore as well, but it'd be nice if I type control space in here, it would suggest the keys that are valid for this particular thing. So that's sort of on my to-do list. Okay, so I'll leave a couple of minutes for questions and then I'll hand it over to Cedric. And I'll put my glasses on so I can actually see you guys. Thank you. So any questions? Clear as mud? Okay, I'll turn it over to Cedric. Unfortunately, I have to run back to the board meeting. I'd really love to be here all day, but other responsibilities. Thank you.